Today we are going to know some fact about the simple machine, and this is a fact that simple machine is a force multiplier. What it means? I want to explain this. Look at this is, let's say, a weight, and it is 100 Newton weight, let's say 100 Newton weight, and direction of weight is vertically downward because weight is the force acting on the body towards center of the earth. That's why this body is pulled towards the center of the earth by 100 Newton force. That's why its weight is 100 Newton. If we want to raise it vertically upward, then certainly we need to apply 100 Newton force in the vertically upward direction to raise it. And there's no chance of raising the same body with less than 100 Newton force if we walk with bare hand. But when we apply certain machine like lever or other simple machine, then the same 100 Newton load can be raised by using less effort, maybe 20 Newton or maybe 50 Newton also. Now this is very interesting matter. How can we raise a heavy load by using less effort? If it is so, then the simple machine which can perform this work is called force multiplier. Okay, let's talk about this. Let's take one example. This is, let's say, a lever, and we're going to raise a load of 100 Newton by using this lever. And here we have fulcrum, and we are applying force at this place. And actually what is happening here, when we apply certain force at this place, let's say F1, then the lever turns, and lever turns, it will turn this way, and the load will be raised to this height. And let's say this is the distance covered by the force, and this is displacement exactly, and this is represented by S1. It means F1 is the force applied on the machine, S1 is the displacement. Force and displacement both are here. That's why we can say that F1 into S1 is work done. Force into displacement is work done, and this work is done on the machine. That's why it is called work input. Wi equal to F1 into S1. Work is done in this part of the machine, and this can be represented by Wi. As a result of this work input, work done on the machine, a load is raised to certain height. Let's say it is raised to S2 height. I mean to say displacement of load is S2 because it's not equal to S1. And how much force is needed to raise this load to S2 height? Let's say that is force F2. It means here also force and distance both are involved. It means work is done at this place also, not only in this place. This work done is called work done by the machine. Work done by the machine is also called work output, WO, and this is equal to force into distance. Okay, as a result of work input, work output, we got work output. It means how much work is done on the machine, the same work should be done by the machine. If we consider that the friction is negligible, then work input, work done on the machine, is equal to work output, work done by the machine. If it is so, then we can say this way, we can write this way, Wi equal to WO, and Wi is equal to F1 into S1, and WO is equal to F2 into S2. Okay, now let's take the value to understand how it multiplies the force. Let's say this load is raised to just 1 meter distance, 1 meter height. Then S2, in place of S2, I can write 1 meter. And the load is taken 100 Newton. As I told you previously, we are raising a load of 100 Newton. This is equal to 100 Newton. Then what is the result of these two? 100 Newton into 1 meter means 100 Newton meter means joule. 100 joule of work is done by the machine. It is work output. And look at left hand side. This S1 is very high than that of S2. Let's say this S1 is 5 meter. Now we can say here it is 5 meter. Then how much force is needed to raise this load? The left hand side and right hand side should be equal. In right hand side we have the result 100 joule and left hand side should also be the 100 joule. To be 100 we have to multiply with 20 Newton here, then 20 into 5 becomes 100 and 100 Newton meter means joule. Now both the sides are equal. What it means? 100 Newton load is raised by using only 20 Newton effort. This is possible because the effort distance, the distance covered by the effort or force is very high than the distance covered by the load. Simple machine can multiply the force if effort distance is greater than load distance in the simple machine. And this is the real reason of multiplication of force. Okay, this was for today.